Hello, welcome to Unit 4, Lesson 7. We all scream for ice cream. Ready, set, go. So, the ready problems say the side lengths of a right triangle, so it tells us it's a right triangle, ABC are 13, 5, and 12. If 5 is the numerator of cosine of A in the triangle, what is the trigonometric ratio for sine of A? Well, our largest side is always the hypotenuse. So since we're dealing with side angle A in both, right? If we know that 5 is the numerator, that means this is our adjacent side, and that makes this the opposite. Remember, I'll write SOHCAHTOA up here. It's a nice little helpful way to remember our ratios. That sine is opposite over the hypotenuse. Cosine is adjacent. That's a D. Adjacent over hypotenuse. And tan is opposite over adjacent. So that means the opposite side, 12, sine of A is our 12 over the hypotenuse, 13. Question 2. The side lengths of the right triangle, EFG, are 20, 29, and 21. 20 is the numerator of cosine E. So that is adjacent to E. And 29 is going to be our hypotenuse. So if we want tan of E, remember tan is opposite over adjacent. So this must be opposite E if 20 is adjacent to E. So tan of E is opposite 21 over adjacent 20. Okay, let's go on to our next one. Question 3. The side lengths of right triangle JMS are 16, 63, and 65. So there's our hypotenuse. If 16 is the numerator of sine of J, so angle J, so 16 is the numerator, so this is opposite J. In the triangle, what is the trigonometric ratio for cosine? So we want adjacent to J, cosine of J, because the angle is really important. So adjacent to J would be 63, and the hypotenuse is 65. Okay, this question 4. The side lengths of the right triangle PQR are 35, 37, and 12. So there's our hypotenuse. If 12 is the numerator of cosine of P, so 12 is adjacent to P. In the triangle, what is the trigonometric ratio for sine of P? So we want sine of P, so opposite P must be 35, and our hypotenuse is 37. Okay, question 5. The side lengths of the right triangle XYZ are 33, 56, and 65. So here's our hypotenuse. If 56 is the numerator of sine Y, so 56 is opposite angle Y. In the triangle, what is the trig ratio for cosine of X? We have to be careful here. Cosine of X, so this is adjacent to Y, but that also makes it opposite to X, and this makes this adjacent to X. So we have to be careful. Adjacent to X is the same as being opposite to Y. So cosine of X is actually going to be 56 over 65. It's the same value as sine of Y. So 56 over 65. Question 6. The side lengths of the right triangle LMN are 39, 80, and 89. So there's our hypotenuse. If 80 is the numerator of sine M in the triangle, what is the trig ratio for cosine of L? Again, remember, sine M, so let's see, 80. That's opposite M, which also makes it adjacent to L. So it's going to be 80 over the hypotenuse, 89. So there's our problems 1 through 6. Okay, problem 7. It says solve each equation. Identify extraneous solutions, if there are any, right? So the first one, I see that I have an x in the denominator. So let's get that out, right? We can assume that x isn't 0. So assume that's not how you spell assume. Assume x does not equal 0, since we already have an x in the denominator, so that allows me to multiply everything by x. So I'm going to multiply both sides by x. Now there's lots of different ways you can do these. I just find it easier. I find that most people prefer, I should say, not necessarily easier, most people prefer to get rid of fractions. So that gives me x squared plus 2 equals 3x. Remember, I have to multiply both sides. So this is quadratic now. So I want to get it equal to 0 to solve. So I'm going to take that 3x and move it over. So it becomes minus 3x plus 2 equals 0. So now this one is factorable. So I'm going to go ahead and factor. So I'm going to factor, because I can find factors of positive 2 that add to negative 3, right? So factors of positive 2 are negative 2 times negative 1, and those do add to negative 3. So I'm going to plop those factors in. There is other methods for factoring, or even using the quadratic formula if you prefer, but that allows me to take each one of these and use the zero product property to set them equal to 0. So I'm going to add my 1 to both sides, and I get x equals 1. X minus 2 equals 0, so I'm going to add 2 and get x equals 2. Now let's check to make sure those aren't extraneous. If I look at my first problem, we already said that we're assuming that x cannot be 0. That's 0 is not part of my assume x cannot be 0. I meant to put, but 1 and 2 are fine. If I plug 1 and 2 into the equation, 2 over 1 is just 2. And 2 over 2 is just 1, right? But if we want to check, never hurts to check, to fully check. So let's check x equals 1 first. So we get 1 plus 2 over 1. Does that equal 3? Yeah, it does. 3 equals 3. So we're good. Let's check x equals 2. So we get 2 plus 2 over 2. Does that equal 3? Yeah, we get 2 plus 1. So we get 3 equals 3. So both of our solutions work. So we get 2 solutions there. Okay. Let's move on to question 8. I'm just going to make sure that our questions are separated here. There we go. There we go. I'll do that for all of them to start. Give ourselves some semblance of what space we have to work in. Okay. I cut off my 1 there. Okay. So let's go to question 8. This time, again, we have another x in the denominator. We can do this one very similar to we did the last one. Let's get rid of the whole denominator. So multiply by everything by 3x. Now, note x, again, cannot equal 0. It's not part of the domain. Since I have 3x in the bottom, if x was 0 there, I'd get an undefined fraction. So and actually, instead of multiplying by 3x, let's multiply by 6x. That's going to help get rid of this 2 as well. That 6 and 2 will cancel out to get a 3, and x times x is going to give us x squared. Here, the 6x over 3x is just going to give us a minus 2. And here, the 6's go away, and we're left with an x. So again, this is in quadratic form now, so let's get it equal to 0. This gives us 3x squared minus x minus 2 equals 0. So you can do any method of trying to factor, or even the quadratic formula if you want. I'll show this using what I would call the AC method, where we do 3 times negative 2, which is negative 6. We take our leading term and our constant number, and we want to find terms that add to negative 1. Well, that would be negative 3 times positive 2. So negative 3 times positive 2 add to -1. So we can actually rewrite our terms. We can replace that minus 1x with -3x plus 2x minus 2. And this is a little bit longer method, but it's kind of a foolproof way of factoring. So I'm going to take 3x out from both, which leaves me x minus 1. And then here I'm going to take a positive 2 out of both, which leaves me again x minus 1. So I have a greatest common factor of x minus 1 in both terms, so I can take that out. And then I'm left with 3x plus 2, and I now have it factored. So that's one way to get those solutions. You don't have to do it that way, but I think it's fairly quick and a little bit more structured than just guessing and checking. So x minus 1 could be 0, so we get x equals 1, or 3x plus 2 is 0, so we get 3x equals -2, or x equals -2/3. So neither of those are numbers we excluded from our domain, but let's just check our work to be case. So first let's check x equals 1. So we get 1 over 2 minus 3 times, minus 1 over 3, because 3 times 1. Does that equal 1 over 6? Well, I can write these both, instead of 1/2, I can write this as 3 over 6, and I can write this one as 2 over 6, which does in fact give us 1 over 6, so that one checks out. Now let's check x equals -2/3. So -2/3 divided by 2 minus 1 times 3 times -2/3. Well, the 3's go away. I'm just left with minus 2. So does that equal 1 over 6? Well, this minus 1/2 can actually just be minus -1/2 can just be plus. So I end up what I'm really doing here is adding -2/3 plus 1, right? Because I don't have a lot of space here. Let's make this, it's going to become really small, but that's okay. There we go. So I'll zoom on in here so we can see what's going on. There we go. So -2/3 plus 1 I can add, because the denominators are the same, I can add those. I could get rid of the denominators first, but why not add them? That gives me, well, 1 is the same thing as 3 over 3. So it really gives me 2/3 over 2. Does that equal 1 over 6? Well, this 2/3 over 2, I'm going to write it here a little bit. Does that equal 1 over 6? Well, remember, I can leave that as 2/3, and I can multiply by the reciprocal of the denominator. So I can multiply that by 1 over 2, which isn't going to give me 1 over 6, but hold on, I think I made a mistake somewhere. Let's go back. And I did. Silly me. This is why it's always good to show your steps. -2/3 plus 3/3 becomes 1/3, not 2/3. So I'm left with 1/3 times 1/2, which is in fact 1 over 6. So yes, that one checks out. Okay. Anyways, question 9. So here we have an x plus 2 in the denominator. So we'll keep the same method going, where we're multiplying to get rid of our denominators for this one. So note here, though, that x cannot equal -2, because that would make this bottom 0. So let's multiply this whole thing by x plus 2. I'll kind of go underneath here, because this one, nothing reduces out, so we're left with 2x times x plus 2. Here, these reduce out entirely, so we're left with plus 3. And here we're left with x plus 2. So our next step then is to distribute this 2x. So 2x times x is 2x squared plus 4x plus 3 equals x plus 2. So again, I want to get this. I have an x squared term and a few x's, so I want to get this equal to 0. So 2x squared, I'm going to move this x over. So I get 3x. I subtract the x on both sides. I'll show that actually. I'll write minus x underneath. And I'm going to subtract 2 from both sides. So minus 1 equals 0. Okay, now let's look to see if we can factor this. I showed the AC method on the last one, so this one we'll just sort of guess and check, especially where we only have a couple options here, right? The only factors that multiply to 2x squared that we can put in factored form are 2x and x. And here we have a negative 1, so it can only be, a minus 1 and a plus 1. So let's sort of just, let's plug our minus 1 here in our plus 1 there. And now let's verify to make sure those actually do add to 3, right? So here we get 2x, and here we get minus x, so that's no good. So let's pause and think for a moment. And the reason why this wasn't working out, because this should be a plus 1, which makes both of these positive. There we go. So silly mistakes, always good to sort of, if something feels off, go back and look. So 3 plus 3 minus 2 is positive 1. So they're both positive ones. That's our only possible solution, and that does check out. So let's go to our next step. We're going to take each one and set them equal to 0. So 2x cannot, or 2x is negative 1, sorry. That gives me an x is negative 1/2. I'm going to go ahead and circle these answers up here. Sorry, I'm backtracking a little. Okay, and then also x plus 1 equals 0. So x equals negative 1. So those are 2 answers. Again, you can check these to be sure. I'll skip that part. This one does check out. We already said that the number we need to avoid is negative 2. And neither of these came out to negative 2, so we can accept these as true. Please, please, please go ahead and check your work for some extra practice, though. Okay, question 10. So here, let's think what x can't be first. So let's do a little note. So here we have x squared minus 2x. That can't be 0. So I'm going to factor an x. Now, that means our x can't be 0, or x can't be 2. Now that's already existing here, so x minus 2, that gives us x minus 2 equals 0. Another x can't be 2. So those are the 2 numbers we're excluding from our domain, and since I already factored this, let's leave it in factored form, because that's what number, that's the term I can multiply by. So I'm going to multiply everything by x times x minus 2. So for this first one, the whole denominator goes away, and we're left with just a 2. Minus here, my x minus 2's go away, and we're left with 1x, or just x. And then equals x times x minus 2, or just x squared minus 2x. I'm going to go ahead and write it like that. So let's bring that up here. I'm just going to move my x squared minus 2x to this side. Now, again, we have something quadratic form, so let's add x to both sides, and then subtract 2. So we get x squared minus x plus minus 2. Oh, today is not my day for science. It's a good thing we are checking ourselves. Equals 0. So, again, we're going to go ahead and factor this. We need factors of negative 2 that add to negative 1. So that's negative 2 and positive 1. Those multiply to negative 2 and add to negative 1. So our 2 values of x become x minus 2 equals 0, or x equals 2. Now we already said x can't be 2. So we're actually going to throw this solution away. This is not possible, or I should call it extraneous. So x equals 2 is an extraneous solution. if we plug it in, we get something undefined. So that one's no good. X can't be -2. Since x cannot equal to, and I'm saying negative, I meant to say positive. So that's one answer. Okay, let's look at the other one. X plus 1 equals 0. That gives us x equals -1. We didn't exclude that, so that one is okay. We can have x equals -1. So we only have one solution for this problem number 10. Okay, problem number 11. We have a 2x minus 1 in our bottom. So let's first note what we can't include. So 2x minus 1 cannot equal 0, which means 2x can't equal 1. So x cannot be 1/2. So if we come up with a solution of 1/2, we know we need to exclude that number. So let's multiply both sides by 2x minus 1 to get rid of our denominator. I'll do this underneath. So that leaves us with 3x times 2x minus 1 as our first term, minus 1 as our second term, equals 4 times 2x minus 1. Okay, so let's go ahead and distribute that 3x, so we get 6x squared minus 3x minus 1 equals 8x minus 4. So let's combine some like terms here and get this equal to 0. I'm going to subtract 8x from both sides and add 4 to both sides. So that gives me 6x squared minus 11x plus 3 equals 0. Okay, for the sake of practicing multiple strategies, let's do the AC method here. Let's do 6 times 3, which gives us 18. So I want factors of 18 that add to -11. So add to -11. So I have a positive 18, negative. So these are both going to be negative numbers. So -2 times -9 are numbers that add to -11. So I'm going to rewrite my expression as 6x squared minus 2x minus 9x plus 3. And the order of that minus 2x and the minus 9 truly does not make a difference. I'm going to group these together, and I can take out a 2x, which leaves me 3x minus 1. And I'm going to group these together. Since I want a 3x minus 1, I'm going to take out a minus 3 this time. That gives me positive 3x minus 1 in parentheses. So one of my terms is 3x minus 1, and the other term is 2x minus 3. So I'm going to go ahead and set both of those equal to 0. So 3x minus 1 equals 0. So 3x equals positive 1. So x is 1/3, and that one is fine, right? We did not exclude that from our answer. We only excluded 1/2. So now let's also do 2x minus 3 equals 0. Equals 0. So 2x equals 3. So x equals 3/2. Again, that is fine. We didn't exclude it as not being part of the domain. So there are two solutions for this one, 1/3 and 3/2. Question 12. So question 12, we have a lot going on down here in the denominators. So let's start by looking at each one here. I can actually factor an x out. And that makes it a little bit easier to see. And notice it looks like a lot going on, but those are the two terms. We already have an x as one of the denominators. X plus 3 is the other one. So this one isn't as bad as it maybe looks at first. But let's see, what can't we include? What would make our bottom 0? Here I see a 0 would make that 0. And here, a minus 3 would make that denominator 0. Minus 3 and 0. So we've already excluded the two numbers. So we're all set. It's just those two numbers that we cannot include in our final answers. Those aren't part of our domain. So let's multiply everything by x times x plus 3. In this one, those go away entirely, and we're just left with a 2x. For our second one, x plus 3's go away, so we're left with minus 2x. Okay, so 2x minus 2x. And then our last one, the x's go away, and we're left with 2 times x plus 3. Okay, let's bring that up here. 2x minus 2x is 0 equals, I'll distribute this. Actually, you know what? There's no need to distribute it. Let's just leave it as it is because I nicely have something that's already equal to 0. Now this isn't quadratic now. Notice there's no x squared terms anywhere here. So I don't have a quadratic function. I can solve this just like a linear. Since I have my 2 out front, let's go ahead and divide by 2. So I get 0 equals x plus 3. And if I subtract that 3 from both sides, I get negative 3 equals x. But remember, over here, I said that can't be. So for this one, there's no real solution since x equals negative 3 is not part of the domain. It is an extraneous solution. So we have no real solution for this problem. Okay. Let's move on to question 13. Channing takes twice as long as Dakota to complete a school project. It takes them 15 hours to complete the project together. How long will it take each student to complete the project if he works alone? So let's start with, let's let x equals how long Dakota takes alone. I could have picked either one, but I picked Dakota. So remember, if we're talking about work, the amount of work we accomplish is basically the rate at which we work multiplied by time. So we know how much time they worked. So work, and let's do, if I know the time, work divided by rate is going to give us our time. So they finished one job, right? So one job. So 1 over, well, actually, let's do this a little differently. I can also say, since I know I'm solving for that time, either one of those ratios is true. So let's say this is Dakota here. So 1 over x. Well, it says that's how long he worked for alone. Plus, Channing works twice as long, so whatever that time is, it's double for Channing. And we know that together, they only spent 15 hours. So one job, and there's our times. That's going to give us an equation to solve. So now let's multiply everything by 30x. That's going to get rid of our denominators. So here the x's cancel out, and we get 30. So essentially, we get 30 plus here 2x, 30x over 2x is 15. And here, the 15, 30 into 15 becomes 2x. So we get 2x equals 30 plus 15, or 45 equals 2x. That's actually right there that we have Channing's time, but let's solve for x. So we get 22.5. We said x is equivalent to how long Dakota works. So Dakota works for 22.5 hours alone. Or I should say would work for, because it said how long would it take. Would need to work for 22.5 hours alone. And Channing would need to work for 45 hours alone. Because it is twice as long. So 45 is twice 22.5. So there we have it. Question 14 says a print shop can print an Algebra 2 book in 24 minutes if both of their print machines are working together to do the job. If a print machine is working alone, the job takes longer, right? That makes sense. Machine A can print the book in 20 minutes faster than machine B. How long does it take each machine to print the entire book? Okay, so this is fairly similar to question 13. Let's start by setting our x. So let x be, let's see, how long does it take for each machine? So let's say let x be how long it takes machine. Now there's not a right or wrong answer here. It says machine A can print the books 20 minutes faster. So let's just say it's machine B. You can put A or B. It doesn't matter. Your equation will look a little different. So if I say it's machine B, remember, so they're doing one job. So let's do this B. So machine B is 1 over x, how long it takes, plus 1 over, well, if machine A is 20 minutes faster, I'm going to put x minus 20. I'm just going to take away 20 minutes from whatever B's time is. And I know that working together, it takes them 24. So 1 over 24, that's our work over time. So we're basically adding our rates together. Okay, so let's get rid of our fraction. Let's divide everything by, well, the 24, we'll get rid of our 24 here. And x, we'll get rid of this x. And then x plus 20, I'm going to give myself a little more space here. So 24x times x minus 20, not plus 20. There we go. That will eliminate all our denominators. So here in our first denominator, the x and the x go away. So I'm left with 24 times x minus 20. Okay, and in our next one, let's do blue here. Our x minus 20 and our x minus 20 reduce. So we're left with plus 24x equals, and this last one, the 24s go away. So x times x minus 20. So let's multiply here. We get 24x. Well, 24 times 2 is 48. So 24 times 20 is 480. So negative 480 plus 24x equals x squared minus 20x. So let's just go ahead and move those up here. Give us a little more space to work. So if I add, let's get all my terms to one. Well, let's combine terms first. I'm going to put my x squared minus 20 on this side equals 24 plus 24. That gives me 48x minus 480. So I'm going to subtract my 48x from both sides and move that negative 480 over. So I'm going to get x squared minus 68x plus 480 equals 0. So 480 certainly feels like a big number, but we know that 48 is 6 times 8, and we want them to add to 68. So 480 can be 60 times 8, which does add to 68 since we want both of them to be negative. So x minus 60 times x minus 8. Those multiply to positive 480 at the end there, and they do add to negative 68x. So we get x equals 60 and x equals 8. Now it looks like we have two possible answers here. And both of these are included in the domain. We don't have a problem there. However, 8's not a possibility. Because if we think back to this, right, if it only takes machine B 8 minutes, this is machine A, well, if machine A is 20 minutes faster, then we're going to have negative time here. And although machine A is fast, it's certainly not negative 12 minutes fast. So this is not possible. It doesn't work. So we're going to use 60. So 60, we said let X be the time it takes machine B. So machine B takes 60 minutes alone. And machine A, well, machine A is 20 minutes faster, so machine A takes 40 minutes alone. If you set your problem up so that X was equal to machine A, you would have had an X plus 20 instead, and your answers would have came out a little differently. You would have actually ended up with a 40 as your answer and realized you had to add 20 to it to get to the 60, but you should have still gotten the same two answers. All right, so there's question 14. Let's move down to question 15. Question 15 says the scenario in problem 14 generates an extraneous solution. Neither solution makes a denominator equal to 0. Why can't we use both solutions? So we actually did already talk about this, but x equals 8 was extraneous since it would have meant, let's rewrite that machine A time alone is 8 minus 20 minutes, and negative 12 minutes is not a possible time. Now, if you solved this in a different manner, you might have had a different extraneous solution, but it should have had the same reasoning, that when we compared it to sort of what the other option was, it gave you something that wouldn't be possible. So there we have it. That's why we have an extraneous solution, even though 8 is part of the domain. But this is where word problems differ from typical equations. Word problems have usually more restrictions than just the original equation. If we only looked at the equation here, it would have looked at the only two not possible answers are 0 and 20. And we know that, in fact, there's only one correct answer here, not a plethora of correct answers. Okay, let's move down to question 16, the Go problems. It says perform the indicated operation. It does tell us that denominators cannot equal 0, which just gives us the liberty of simplifying without having to worry, are we dividing by 0 at any point? So let's start by factoring. It says divide out all common factors, so we have to factor. So let's think of factors of 12 that add to 8. So 6 times 2, well, 2 times 6 is 12, and 2 plus 6 is 8, so we get x plus 2 times x plus 6. Usually a little hint is that some of these factors are often the same. If it's telling us we divide out the common factors. So an 18, so let's see if we have an x plus 6 is another factor. So negative 18 divided by 6, the other factor would have to be x minus 3. Let's see, x minus 3 times x plus 6, that does give us a minus 3x and a plus 6x, which gives us that plus 3x. So these are all set. That means our common factors are x plus 6. And we can divide that since we know that the denominator is not equal to 0. So rewrite, dividing out all the common factors, we're left with just x plus 2 over x minus 3. Problem 17. So we want to factor x squared minus 3x minus 40. So factors of negative 40 that add to 3. And if you're stuck, write them off to the side, right? 1 times negative 40, that's no good. 2 times negative 20, that's 18. 3 doesn't work. 4 times negative 10, that's no good. 5 times negative 8, there we go. So that didn't take me too long. So x plus 5 times x minus 8. Again, use that numerator as a hint, right? I now want factors of positive 24 that add to negative 11. I'm going to assume maybe one of them might be negative 8, right? Negative 8 times negative 3, those would give me positive 24 and would give me negative 11. So x minus 8 times x minus 3. The order that I write the factors in doesn't matter. I'm still able to reduce out both x minus 8, so I'm left with x plus 5 over x minus 3. Okay, this one wants us to add. Before we can add, we need to make sure our denominators are the same. So I can see that those aren't exactly the same, but let's factor them to see if there are some common factors. So let's factor the numerator and the denominator for both to start. So I'll do this one. Let's color code this to make it a little bit easier to follow. So I'll do this one in pink. So we already factored this, actually. It's the same problem as 16. So factors of 12 that add to 8 are plus 2 and plus 6. And we already did this one, right? That's the same with question 16. So x minus 3 times x plus 6. So we do see that we can reduce there. I'll do that after. Okay. Let's do this one in green. So here, this is the same problem in 17. We're going to get x plus 5 times x minus 8. We already factored that above. And x minus 8 times x minus 3. So really that's problem 17 and problem 16 just put together. So now let's see what reduces here. So the 8's reduce, the x minus 8, and the x plus 6. So we're left with just x plus 2 over x minus 3 plus x plus 5 over x minus 3. So our denominators are the same. That should definitely make us smile, which means I can add my numerators. So the denominator stays the same. It stays x minus 3. X plus x is 2x, and 2 plus 5 is 7. If I could factor that more and reduce, I should, but I can't factor anything out of 2x plus 7, or not an integer number at least, so we're going to leave it as 2x plus 7 over x minus 3. Okay, question 18 wants us to multiply. Let's always try to reduce first as much as we can, and it'll make our numbers a little easier. So I don't see any common factors with the ones that are already sort of simplified here. So let's factor x squared plus 5x minus 36 to start. So let's think of factors of negative 36 that add to positive 5. So if they're adding to a positive, that means my bigger number is positive. So let's start with, negative 2 and 18. Those add to negative 16, so that's no good. Negative 3 times 12. We're getting closer. Negative 4 times 9. There we go. Those add to positive 5. So this can become x minus 4 times x plus 9 over x minus 4 times 3 times x plus 2 over x plus 9. And I didn't need to put that x plus 9 in parentheses, but why not? So now let's see if we have any common factors. Here are x minus 4 and x minus 4 are common factors, so they can go away. And here I also have this x plus 9 and x plus 9. It's okay that they're in separate fractions because everything is now factored. So that means everything from that first set of so that first fraction went away, reduced, and we're only left with 3 times x plus 2. There we go. Okay. Question 20 wants us to subtract. So let's go down to question 20. So again, we want to factor this first so we can see, do we have any common denominators? So I want to factor x squared minus 4. That's a difference of squares. Difference of squares. So it can factor as x plus 2 times x minus 2, which means my common denominator is that. So that's the common denominator. So to get that, I need to multiply this top and bottom by x plus 2. And I'll put it in parentheses. I don't need them, but makes it a little nicer there. So that way, both of these fractions now have the denominator of x plus 2 times x minus 2. So the first one doesn't change at all. So x plus 2 times x minus 2 minus, now 1 times x plus 2 becomes x plus 2, and it's over x plus 2 times x minus 2. Now that I have those common denominators, I can add my numerators together, but be really careful. When I'm subtracting, I have to distribute the negative. So I'll actually write this in 2 steps. Instead of doing it all at once, where we tend to make mistakes, it's nice to show the negative sign there. And then in my next step, I can actually distribute it for minus x minus 2 over x plus 2 times x minus 2. Okay, so my next step, let's combine my positive 4 and my negative 2. That gives me plus 2. Okay, so over x plus 2, x minus 2. Now, that doesn't match either one, but I can see that they're close, right? So let's factor out a negative here, actually. Let's make this negative 1 times x minus 2. Now, I have a matching term in the top and the bottom. Right, now that I factored out that negative, I can say, oh, those go away, and my final answer is negative 1 over x plus 2. Okay. Question 21. So question 21 says to divide. Again, we're going to have to factor this before we divide. So let's factor our numerator right here. So factors of negative 3 that add to 2, that's going to be minus 3 and positive 1. When we divide, we multiply by the reciprocal. Multiply by the reciprocal. Reciprocal. Gotta sound it out. Okay. So I'm actually going to change this to multiplication and flip my fraction. So now I'm looking for common terms. Here I have x minus 3 and x minus 3. Those go away. So I'm left with a 5 and an... Oh, wait, we missed one. Let's see. I can reduce a little bit more. X plus 1 and x plus 1. So everything in that first fraction canceled out, and we're left with just a 5. So our final answer for this simplifies down to just 5. All right. And that is our last problem for this Ready, Set, Go. So thank you for watching, and hopefully you found this video helpful.